All right, so now we're on to the final unit of the course related to programming. And this is probably one of the more critical units that you're going to learn in your fundamentals. So what we're talking about today is something called loops, more specifically counted loops. So what do I mean by that? What is a loop in the first place? Well, a loop is just a series of actions that you repeat. And when I say repeat, I mean the exact same way every single time. So for example, that might be, maybe you have a music playlist set up on your phone. You might have 10 songs, and when the songs are done, they go back up to song 1 and they go through the process again. So you have it on loop mode, repeat mode. Or maybe you're just your daily routine. You wake up every day, you go to school, you do your homework, you relax for a bit, you go back to sleep, and you get up and you do it again the next day. And we do that for 5 days a week, every single week for 10 months of the year. 3 tries to enter a password into your phone. Well, depending on the type of phone you have. I think Apple is like 10 tries or something like that. But eventually what it's going to do, it's going to lock you out. So it gives you all these opportunities. But the process is exactly the same every single time. Enter username, enter passcode. If it's a phone, it's just enter passcode, enter passcode, enter passcode. In programming, it's the same idea, but now we have to specifically apply it to code. So in programming, a loop is a sequence of instructions that is continually repeated until some kind of end condition is met. It has to end at some point. So when, or what are the conditions? Well, that depends on the problem you're trying to solve. So in programming, we use the term iteration to represent one full cycle of a loop. So I might say, hey, how many times does that loop iterate? Or what iteration did that error occur on? So this gives us a more formal way of saying a cycle of a loop. Okay, so here's some programming examples. There's that password program again. Somebody has to code it, right? It doesn't just come out of thin air. So somewhere somebody wrote a loop of code that will ask the user for that username and password, and if it fails, it will try again and again. Analyzing a string. So you might have a string, maybe hello world or something like that. And maybe you want to go through it character by character doing something with it. For example, maybe you want to encrypt it. So you might say, okay, well, if I have an A, what am I going to shift it by? How many characters am I going to shift it by to encrypt it? Maybe you're analyzing a string for another reason altogether. Maybe you're looking for the first space inside of a string so you know where the first word ends. Right? So something along those lines. You'd have to go through one character at a time. Repeating a process such as drawing 10 of one thing on a screen. Maybe you have an array of 10 enemies in a game that you're making, and you want to loop through and draw each one of those enemies on the screen. Game loops themselves, we already know that this is a loop that continually goes 60 times a second, and in each iteration of the loop, it does 2 methods, update and draw. Animation itself, animation continually loops through all the images in a single animation over a period of time. So it might be like 10 frames of animation, but you want to show each one of those frames for a few updates, right? And so when that animation completes, it's going to come back and start the whole process again, depending on what you're trying to animate, I guess. Working with arrays, this is going to be the be-all, end-all of efficiency in your programs at this stage in your programming career. So for example, if I have 1,000 student names and I want to display them on the screen, or I want to loop through them and try and find all the ones that have a last name that start with the letter L, I can do that with a loop. If I don't, I have to do that with separate if statements and checking every single one of those students. No thanks. No, don't want to do that. Sorry about that. Where was it? So let's go on. If it's going to cycle, there we go. So let's talk about a few simple examples that having a loop would make life a little bit easier for. So let's say I had a range of numbers from like 1 to 1,000, and I want to output the sum, the addition of all of those numbers. Now I could manually do it, 1 plus 2 plus 3 plus 4 plus 5, and yeah, that wouldn't be a problem. So we have our code, sum is equal to sum plus 1, sum is equal to sum plus 2, and we continually do that till we get up to 1,000 lines of code, and that would work. Right? So basically what are we doing on each step? We're saying for each number from 1 to 1,000, let's compute the new sum as sum plus number. That's a lot of work. That's 1,001 lines of code just to display the sum of those numbers. We want to be able to do that much, much quicker and with much less effort. Maybe we want to set all the numbers in a 3-element array to a random value. Let's pause for a second. All right, sorry about that again. So let's say we want to set all the numbers in a 3-element array to a random value between 10 and 20. We could do that, and it would look something like this. If I can get my code to go. There we go. So we create the array of 3 elements, and then one at a time, nums at 0 equals, get the random number between 10 and 21. Nums at 1 equals, get the random number between 10 and 21. Nums at 2 equals, get the random number between 10 and 21. That's not really so much of a problem until we want to do, say, 300 of them. Now we're looking at a separate line of code for every single one of them. Maybe we want to do 3,000, 3 million. That's not attainable. We don't want to work with that kind of stuff. So this is where loops is going to become real powerful. The point of loops is to automate effort. So instead of us manually doing every single step, we want to generalize what we're doing so it is the same step every single time. Maybe the only thing that's different, so for example, the only thing that's different in each one of these lines of code is the index into the array. Up here, the only thing that's different in each one of these lines of code is the number that's being added to the sum. Other than that, the code is identical. Well, these are just values. We can change those. That's what the point of variables are for. And that's what we're going to do. So in programming, we use the term a for loop. A for loop is a counted loop that iterates a specific number of times. Now, what do we mean by that? What I mean is that, like, we might say, I want to create a loop that loops exactly 5 times. But we're actually going to be more specific than that. We're going to give it a range. So we might say, I want to loop from 0 to 10, or I want to loop from 5 to 22, or I want to loop from 10 down to 4. Whatever you want, you're going to set up a range, a starting value and an ending value. So in Java, a counted loop is also called a for loop, but pretty much in every programming language we use the term for loop. I can't really think of one off the top of my head that that is different from that. There are different flavors of for loops, mind you, but typically speaking, for loop is the general term. For loops are made up of 4 parts. So 3 parts that actually define the loop itself and set it up. So it says, okay, I'm going to loop from here to here. And then one part, which could be made up of many, many lines of code, which is the code to be executed each iteration of the loop. So we have that first piece. Piece number 1, we want to define our counter variable. So this is going to be used to count the iterations as we go through. Then we're going to compare that counter variable against an end value. So maybe, for example, I want to loop from 5 to 10. My end value there is 10. Okay? Code. This is the code that's going to be inside the loop, and this is the code that's going to be executed in each iteration of the loop. And then finally, we have the change. So this is when we are going to change the counter variable in a manner that gets it closer to the end value. So for example, if I'm looping from 5 to 10 and I want to hit every step along the way, I might add 1 to the counter variable every single time. So maybe it starts at 5, then it goes to 6, then 7, then 8, then 9, then 10. And what we can see here is that it is getting closer to that end target value every single step. If we make a mistake and we accidentally go the wrong direction, well, that's going to cause a really big error. If I subtract, for example, and that loop says keep looping until I get to 10, well, you're never going to get to 10, ever. So we get stuck in what we call an infinite loop, which is definitely something we want to avoid. There we go. So here's an example of a count of a for loop inside of our code. In this case, we're saying we're going to loop from 5 all the way up to, but not including 10, and we're going to add 1 to that count variable every single step. So we see 3 of the 4 parts here. The 4th part is the code, which goes inside. That's the code that's, in this case, all I'm doing is displaying the value of the counter variable. Oh, I have a typo. That should just be count. We'll come back and I'll fix that after. All right, so our for loops. Let's see here. So let's start looking at each individual part. So part number 1 is all about defining that counter variable. So here I'm actually creating a brand new variable, and it actually gets defined as part of the for loop. Now, I don't have to per se, What I mean by that is I can actually define the variable before the for loop if I would like. The benefit of doing that means that I actually have access to that variable when the for loop is done. If I don't, like for example on the previous slide, here I'm defining the variable, the int count equals 5. I'm defining it right here as part of the for loop signature line, the statement, the for statement. Now, I could have done int count above that for statement, which means it's not actually part of it. We're just going to use it inside of that. And that is perfectly reasonable to do, but it's not common. And it's not necessary usually. But if for some reason you actually need access to that variable outside and after the loop, yes, that's the course of action you're going to want to take, is define your variable, your counter variable, before the loop. Now, as I said, normally you're going to do it as part of the loop itself. All right. The start value. This can be anything you want, any integer, because as we can see, our count variable itself is an integer and must be an integer. So our start value has to be an integer as well. So you could use literal values here, like you saw in my example. I set it to 5, or it could be a variable if you wanted it to be. It could be anything you want as long as it's an integer. Okay. The name of the counter variable, now you can see here I'm using the variable name count. And the only reason I used that was to keep it simple so you understood that that's what it represented. But typically speaking, we like to shorten things up in our code. And now this is the one time that you're ever really allowed to do this, is instead of having a descriptive variable name, typically speaking, we use the variable names I and j for our counter variables. And what that does is it simplifies the amount of code that we're writing. And because it's a standard, everybody does this. Because it's a standard, that means that people aren't confused by that. They say, well, when I see that I variable name, that means that you want me to actually create, that actually represents a counter variable for a loop. So I understand that, okay? So as I mentioned before, your count variable, I or j or whatever you're going to call it, it must be an integer type because we're talking whole numbers. Loop from 5 to 10. You can't say loop from 5.5 to 10. Doesn't work like that. So now after we've defined our variable, we want to create our comparison. So basically this is an if statement without the if. It's the comparison logic. A comparison statement that says if this statement is true, continue looping. If it fails, you're done looping, stop. So here's 2 examples. I might say keep looping as long as count is less than 10. So that means 5, 6, 7, 8, and 9. It would not do 10 itself. Whereas this one over here, count is greater than or equal to 0. That says keep looping as long as count is at least 0, which means 0 is included here. So the end value, here I'm using 10 and 0. Those also need to be integer types, of course. And the end value, depending on whether you're counting up or counting down. If you're counting up, that means the end value has to be bigger than where you started. If you're counting down, that means the end value needs to be smaller than when you started. If it's not, you're going to get an error, and you're going to get that infinite loop that we have issues with. So the loop's going to continue to repeat as long as that test evaluates to true. So it's just like an if statement. It'll execute the code inside if the condition is true. For loop is the same thing. It will execute the code inside as long as the test condition is true. There we go. So when does the test occur? The test actually occurs before you ever even get into the loop for the first time. So it is possible that depending on what the value of your start value is and your end value are, whatever, if they fails the test condition on the very first time, it will never ever enter that for loop. So you have to be conscious of what your start and end values are. You may have created an impossible situation, in which case the code doesn't actually do anything. So the final step is the change step. So this is where we want to modify our counter variable to make it proceed towards the end value. Are you counting up or are you counting down? So in this case, you can see I'm adding 1 to count and then storing it back in count. Over here, I'm subtracting 1 from count and I'm putting it back into count. So the amount you increase, decrease by, that's what we're talking about when we talk about the change step. Now that value can be anything you want. Here you see me adding only 1 and subtracting only 1. It can literally be anything you actually want. So in these examples, the first one I'm adding 5, and the next one I'm actually dividing it by 2. So it's actually cutting it in half every single step. And this one, I'm putting it through an exponent calculation and I'm squaring it every single step. So if count started at 5 and I square it, it's now at 25. If I square that again, now it's 25 squared, and continue on, continue on. So it depends on what your goals are and what you need to do. Now, of course, as I mentioned before, if you're not going towards that end goal, well, you're going to get an infinite loop, which means it's going to loop forever. And your program will usually just kind of sit there hanging, and you're not going to understand why you're not interacting with anything. Okay? It is important to realize that if you're using loops in a game context, like inside of like your update of your game, you got to remember that in one update, 1/60th of a second, it's going to try and execute that loop, and it's going to execute the entire loop, right? Because that one loop structure is inside of the update, which happens 60 times a second. So 60 times a second, it's going to execute the entirety of that loop. So be conscious of this when you're doing your game development. Okay, so don't forget that we have a ton of shortcuts to simplify incrementing and decrementing values, like our counter variable here. So for example, if I want to add 1, I could say plus equals 1, or I could just say plus plus. Similarly speaking for subtracting, minus equals 1 or minus minus. So that is something that we typically do to reduce the amount of work we actually want to do in the first place. So let's look at a few examples here. So let's say I want to create a for loop that counts from 1 to 1,000 and keeps a running total of the count. Okay, so I'm basically adding up all the values from 1 to 1,000, which we saw at the very beginning of the lesson with that sum value. So first thing, I'm going to create a variable called total, and I'm going to display that total at the very end. Now I want to create my for statement. Now what I want to point out is you can see that each one of the parts, like the first part ends with a semicolon. We're defining this new variable. Then we're doing our comparison step. It ends with a semicolon. But our third step, there is no semicolon. There's also no semicolon at the end of the for statement. The vast majority of new programmers, this is where they're going to make their mistake. So if you're getting a logical error, look here first. Chances are that's where the problem is. So there should only be 2 semicolons in this whole thing, after the first part and after the second part. So let's break this down here. What we're saying is I want to loop from 1 all the way up to and including 1,000. So my start value is 1. My end value, I want to keep looping. So I want this statement to be true for me to continue looping. So I'm going to loop all the way up to and include 1,000. So it's going to be 1 and then 2 and then 3 and 4 and 5 all the way up to 1,000. You can see because I'm only adding 1 in each step. And then finally, oh, I already went through all this stuff. We get our code inside. So the code inside, I want you to look at the order here. So the first thing that actually happens is we define our counter variable. We test to see whether we should actually do any code. If we should, we're going to go inside and we're going to execute the code inside. But where do you think it goes to next? Well, after this, it's going to go to the change step. And that's where it's actually going to modify the value. So that code actually occurs after the code inside of the for loop. But then where's it going to go? Then it's going to go back to the comparison step. So it actually is going to go 1 to set up, and then it's going to be 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4. 2, 3, 4 is really the loop that we're seeing. Should I go in, do the work, change? Should I go in, do the work, change? And it repeats this process forever. Now up here at the top, I just wrote a simplified version of the exact same code using simpler naming and simpler logic. So this is the exact same logic. So for int I equals 1, such that I is less than or equal to 1,000, and we're going to increase by 1 each step inside total plus equals I. Remember, plus equals adds to itself. So I'm just saying total plus equals I. Add I to itself each step of the way. So that's a much cleaner and simpler way to look at it. It's still easy enough to read, and there's no real question about what's going on here. So that's our first example of using a full counted for loop. Let's move on. So here's an example program. Now what I want you to do is, as I'm going through here, I want you to pause the video for a second and analyze what's going on in this code. And I want you to tell me what the output would actually look like. So if we're starting, look at our start value, int I is equal to 10. keep looping as long as I is greater than 0, and every step of the way we are going to subtract 1 from I. So that means it's going to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then it's going to subtract another 1 and be at 0. But that means 0. 0 is not greater than 0. So it would fail that test. So it would actually end at 1. So we would get 10 all the way down there. Okay, that's fairly straightforward. Let's try another one. So in this case, exact same code. The only thing I changed was every step of the way, I'm subtracting 2. I minus equals 2. So it's still starting at 10 and going all the way down to, but not including 0. So this time I'm going to get 10, subtract 2 is 8, subtract 2 is 6, subtract 2 is 4, subtract 2 is 2, subtract 2 is 0, but 0 will not work out. So we're going to stop at 2 this time. Okay, one more. So in this case, we're starting at 3. And we are going to keep looping as long as I is less than or equal to 12. And every step of the way, we're increasing by 3. So we're going to get 3, 6, 9, 12, which is still okay. It's going to go up to 15, and then it's going to fail that test. So we're actually only going to get up to the 12 in this case. So that's the end of that. So I'm going to do one more slide, which incorporates arrays and our loops. So this is a little bit more complicated one, so if you need to slow things down or come back to this, that's okay. So here what we're going to do is you can see that I've created an array of 10 numbers. All right, now these are all doubles, so I got a whole slew of different values in here. And the next line of code is I'm going to call this method called findAverage, and I'm going to store the result of this function into the variable called average, which is then going to be displayed on the screen. So we can see the first thing that happens is we are going to pass this numbers array into our findAverage method. So nums is really pointing at numbers. Okay? Inside, I've created a sum and an average variable with both start at 0, and eventually I'm going to return that average because that's the point of the method itself. So the first thing I want to do is I want to create my for loop. So remember what I'm trying to do here. I want to find the average of every element of this array. That means I have to look at every element of this array. If you were coding this manually, your sum calculation would be nums at 0 plus nums at 1 plus nums at 2 plus nums at 3. And you would do all 10 values. And that would work perfectly fine, but it's small. And you would have to hard code it for exactly 10 numbers. You would have no flexibility. But with a loop, not only do we not have to hard code every single one, but we can actually make it work with any size array. So look at my loop statement here. For int I is equal to 0, keep looping as long as I is less than nums.length, increase by 1. Now we know that I represents our counter variable. That makes sense. But you know what else I represents here? I represents the index that we need for our arrays. Now think about that. Our array range, our index range, is 0 to length minus 1. Whatever the size of the array is, 0 to length minus 1. Here we only have 10 elements, so it's 0 to 9. Well, that's great because we're saying I is less than nums.length. I don't actually want nums.length because I want 0 to 9, not 0 to 10. So that's perfect. So this is how this actually works. So even if our array had 3 billion elements, we wouldn't have to change a single line of code, a single word, anything whatsoever. We're saying use I as an index, and our first index is 0, and our last index is always going to be length minus 1. And we're going to visit every single index in between. Okay, so what are we going to do in between? Our goal is to calculate the sum. So every step of the way, we're going to say, well, we need to add the current array element to the sum. So it's going to look like this. Sum is equal to sum plus nums at I. Now the first iteration of the loop, I has the value 0. Then we add 1, now I has the value 1. So it's going to be nums at 1. Then 2, 3, 4, all the way up to 9. So we're going to get the entire thing. And every step of the way, we're doing the exact same line of code. So this is what I talked about earlier at the very beginning, is that try and find a way to generalize this. So the only thing we're really changing is some number, some variable within. In this case, the only thing we're changing is the index into the array. Other than that, it's the exact same line of code in every single step. So now we have our sum, and the final bit is to calculate the average, which is just the sum divided by nums.length. Again, because we're using nums.length, this will work with any size array. It doesn't matter how big it is. It could be 1 element, 50 billion elements, doesn't make a difference. It's still going to work the exact same way. And it's not going to require you to add any more code. Logically speaking, we're looking at 1, 2, 3, 4, 5, 6 lines of code. So even if it was 4 elements or 40 billion elements, it would still be 6 lines of code. Still wouldn't require any more effort on your part. So this, ladies and gentlemen, is an example of us using loops to really work with arrays. And that's where they truly become powerful. Now imagine you were building a game and you had an array of let's say, balls that you have bouncing around the screen. Every single update, you could loop through your array of balls and move them by their speed. Every single one of them. If you're using parallel arrays, then maybe every single ball has their own speed. And you would add the current ball to its current array, to its current speed. And again, we're using that I variable as the index into our array. So it's up to you in order to set this up. So anytime you need to loop through an entire array, or even a string, because remember strings work the same way, it's always going to be from 0 up to, so less than, the thing that you're iterating through dot length. And that's going to give you every single element one at a time and allow you to analyze that. So that's it for counted loops. Next lesson, we're going to go on to conditional loops, which is going to be very, very much more straightforward since you already understand the concepts here. Take a look at the practice work and see where you can start applying it. Good luck and have fun.